Have you ever looked at a brand new tire and wondered why it isn't completely smooth? After all, a smooth rubber surface would seem like it should give a car more contact with the road. More rubber touching the pavement sounds like more grip, right? But that's not how a road tire works. Those grooves, channels, and little cuts covering the surface are carefully engineered for a reason. In fact, making a tire completely smooth could make it considerably less useful on an ordinary road. So why are tires covered in grooves instead of being one big smooth piece of rubber? Let's take a closer look at the surprisingly clever design hiding underneath every car, right here, on History of Simple Things. The earliest automobile tires were quite different from the sophisticated radial tires we use today. Early pneumatic tires evolved from bicycle and carriage technology in the late 19th century. As automobiles became faster and roads improved, tire manufacturers discovered that the shape and arrangement of the rubber contacting the road could dramatically affect handling. By the early 20th century, manufacturers were experimenting with tread patterns rather than relying on simple, relatively smooth surfaces. As cars became heavier and faster, tread design became increasingly important for controlling traction, durability, and water on the road. Today, tire tread isn't simply decoration. Engineers design specific patterns for different conditions, from dry highways to heavy rain, snow, mud, and even racetracks. The most important job of grooves on an everyday road tire is dealing with water. Imagine driving over a wet road with a completely smooth rubber tire. As the tire rolls forward, it has to push water out of the area where the rubber meets the pavement. At low speeds, that's generally manageable. But as speed increases or water becomes deeper, the problem becomes more serious. The grooves provide channels for water to move through and away from the tire's contact area. This helps the rubber maintain contact with the pavement rather than riding on a layer of water. That dangerous condition is called hydroplaning or aquaplaning. This is why tread patterns often feature wide circumferential grooves, angled channels, and smaller cuts. They aren't simply removing rubber for no reason. They're creating pathways that help manage water. Here's where things get interesting. On a dry road, a smooth, racing-style tire can actually be extremely effective because it can put a large, uninterrupted rubber surface onto the pavement. That's one reason dry-weather racing tires, known as slicks, can be nearly completely smooth. But ordinary road driving isn't performed on a perfectly dry racetrack. Your tires have to handle rain, puddles, dust, temperature changes, road debris, emergency braking, and constantly changing pavement. So road tires are designed as a compromise. Instead of maximizing one characteristic, engineers balance dry grip with wet performance, durability, noise, rolling resistance, and handling. In other words, those empty spaces aren't necessarily wasting the tire's potential. They're giving the tire capabilities that a completely smooth surface wouldn't have. Look closely at a modern tire and you'll notice that not all grooves are doing the same job. The large channels that run around the circumference are particularly important for water evacuation. Smaller grooves and cuts, known as sipes, create additional edges that can help the tread conform to the road and improve traction, especially in wet or winter conditions. Then there are the large chunks of rubber between the grooves. These are the tread blocks or ribs. Their shape affects how the tire responds when you accelerate, brake, or turn. Manufacturers can therefore change the entire personality of a tire simply by changing its tread pattern. Some designs prioritize quiet highway driving and long tread life. Others emphasize cornering. Winter tires use more specialized patterns and compounds for cold and snow-covered roads. If grooves are so useful, why not make them enormous? Because removing rubber has consequences too. A tire needs enough rubber in contact with the road to transmit braking, acceleration, and steering forces. Excessively aggressive tread can also increase movement within the tread blocks, which can affect handling, wear, noise, and rolling resistance. So, tire design becomes a balancing act. Engineers have to decide how much rubber should touch the road and how much space should be left for water, snow, flexibility, and other requirements. That's why two tires of exactly the same size can have dramatically different tread patterns. One might have broad channels designed for wet highways, while another may use a more compact pattern aimed at reducing rolling resistance and maximizing mileage. As a tire wears down, its grooves become shallower. That doesn't just make the tire look old, it reduces the amount of tread available for managing water and can affect wet road performance. Most modern tires include built-in tread wear indicators or wear bars. These small raised sections inside the grooves become flush with the surrounding tread when the tire reaches the legal minimum tread depth in many markets. Michelin, for example, identifies its tread wear indicators at 2/32 inch or about 1.6 millimeters. That's why simply looking at whether a tire still has some tread isn't enough. The depth and condition matter. So the next time you look at the grooves on your tires, don't think of them as gaps where rubber could have been. Think of them as tiny engineering systems. Every channel has a purpose. Some help move water, some create biting edges, some influence stability, noise, wear, and handling. And the entire pattern works together with the tire's rubber compound, internal structure, pressure, and the road itself. A perfectly smooth tire might look simpler, but ordinary driving isn't simple. Your tires need to perform when the pavement is dry, when rain suddenly starts falling, and when you have to brake or turn unexpectedly. Those grooves are there because the best tire isn't necessarily the one with the most rubber touching the road. It's the one that can maintain useful contact with the road under the conditions you're actually driving in. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.